All right, let's go ahead and do this review. All right, so first it just starts out with some basics of the normal model. So you know that standard, remember we've written things as the N 0, 1 when we were talking about the standard normal model, and that is the one that has z-scores on it. And of course that area under there is 100%. All right, and so then that's one of the things that we do is check those percentages. Okay, so of course positive 1.2 is 1.2 standard deviations above the mean, and then negative 1.2 is 1.2 standard deviation below the mean. So that variance, I do know there's a question where I, in bold, say the variance that you are given is a number that is squared. That's an easy square, so you have to get the square root of the variance to get the standard deviation. All right, now here's where we were comparing three totally different eras of hitters. And so that's where you have to compare z-scores. Whenever you're comparing things with totally different means and standard deviations, you have to standardize the score so that we can compare them to each other. So once you get those z-scores, of course, what we're saying is Ted Williams was the best because he had the most standard deviations above the mean. So his score was the most standard deviation above his mean, their own particular mean. All right, so here we have the length of orb spiders. And the interesting thing about this one, number 8, was one that took some common sense to figure out, which I don't have any, so it was kind of interesting to come across this and figure this one out. So what happens here is the idea is that the normal model is mostly 99.7% of data is within 3 standard deviations below and 3 standard deviations above. So it's a total of 6 standard deviations wide. So since that is 6 standard deviations wide, if I knew that distance in context, which here it's 126, so it's 126 inches wide, and I'm going to divide that into 6 sections. That would give me the length, the approximation of a standard deviation. So that was 21. All right, and so here, let's see. So the mean, of course, would be that smack dab in the middle. Okay. So then here we have this where, once again, do you remember that if you are finding a standard deviation or a mean, you have to go through the z-score formula. You have to get a standardized z-score by using, so that's the first step. You have to get a standardized z-score by using the normal standardized curve. And then in this case, we did a bound. So we did this with bound, and we did this with 15% to the right. And so then we had that z-score of 1.04. And then our x was 80, because that was I should have drawn a picture here. So we had our x value of 80, which had 15% above it. And then, of course, our mean was there at whatever that is, 60. So this gets in the way. I don't need that to be bigger. So that mean was at 60, okay? So you have x minus the mean over the standard deviation, and then you're going to do the algebra to solve that. Okay, so here's another one comparing two totally different tests that had different means and standard deviations, so we had to get that z-score. And so she did better because she had a higher z-score, also known as she was more standard deviations above the average on test A than test B. More standard deviations above the mean. All right, so 12 is this transformation. It's actually from last unit, and that is that idea where if you want the new mean, then you will put the old mean into the formula, and mean is affected by that multiplication and shift. So it is affected by the 3 times the old mean plus 5. But the standard deviation goes into this transformation, and shift never affects the spread, like that Africa song. And so shift does not affect the spread. So the shift of plus 5 does not change. Once we multiply by 3 and then we shift up 5, we do not have a change. We do not have a change of the spread. All right, and our last one here is like the one up at the top of the page where we had the minimum and the maximum. And so we just took that range and we spread that amongst 6 standard deviations. All right, moving on. Okay, so this is one like we did the very first day we learned normal model. And you don't actually have to do this with this picture here, because I then taught you that you could use the DESMOS. So you would want some kind of picture and labeling it, and then you could also use area in DESMOS. So when you do those percentages, there are approximations, so I will say that it is 95%. If you did DESMOS, you actually got here pretty close to it at 95.45%. And then so on. And so then this was a section that makes about 16%, and this section makes about 97.35%. Here I think it's 97.5. Interesting. Okay, I didn't finish that work on that one. All right, and so now we have these problems about the UT squirrels. And so when you show work, you don't, if you have multiple parts, now I did this, but you don't have to. If I am defining that this problem is about the distance in feet that the squirrel travels around UT, I don't have to put that again on subsequent parts that still have the same context and the same standard or the same mean and standard deviation. Okay, so here we were finding an area, so we would put into our DESMOS, we were finding this area, and it was to the left of 78. And so then that's how we put that in there. And then we, of course, brought down the number so we could get the entire decimal that we turned into a percent. And if you want to turn into a percent, this next one asked about, again, a proportion. So when it asks for it, one of the P words, proportion, percent, percentile, proportion, what is it? Probability. What's the probability that a squirrel will travel a certain distance? So any of those P words are looking for an area, a shaded amount. So that means this is what we're finding here, is this shaded amount. So we want to use area in DESMOS to compute that. And we do the area above those X values to get above or below or in between, whichever one it asked for. And so in this one asked for in between. So in DESMOS, we did the area of the inner area between 80 and 95. And so then there you have that. Okay, and our last one was to find the X value with the upper 10%. So therefore I used bound if I am finding an X, and I do it with context normal distribution if I'm finding the X, and I would do it with the standard normal model if I'm finding a Z. So I use N, 0, and 1 if I'm finding a Z bound. I use context, mean and standard deviation, if I'm finding an X bound. All right, so now here it asks for the IQR, and so I can just put in the context here and find the bounds for the inner 50%, because that IQR spans the middle 50%. So when I do that, that gives me the Q1 and the Q3, so then I can subtract them to get that Q3 minus Q1 to get the IQR. And I should have, yeah, I labeled those as feet here. So see, that one I had done bounds for the inner 50%. I put 0.5 in there. All right, we skipped 16 because that was getting finding a mean and a standard deviation at the same time, and I did not have a chance to teach you that or kind of put you in that section. So here we were transforming, and so that one was dividing by 12 when we were going from inches to feet. Somebody asked me, how do I know if I multiply or divide? Well, think of a common one. So for example, if I have 24 inches, how many feet is that? Well, that would be 2 feet. Well, what did I do? I divided by 2 to go from that inches to the feet, because I was going to something bigger, so my amount of inches was getting into smaller amounts. All right, so this one's interesting. So here we have 2 different populations, and they have different standard deviations, but so they are differently spread out. So you can see this picture here. But the key is, if both percentage of observations fall within 2 standard deviations, it's not asking what's the context out here. It's not asking for the context, which those would be different. It's asking what is the percent of data in between 2 standard deviations. And in both cases, even if the standard deviation is a different size, 2 standard deviations out has 95% of data in the middle. So they are both 95%. All right, now here we have a problem where we are finding the x. All right, so we have the mean and the standard deviation, and we are finding the x in level. And so I should have probably put this mean in here as 30, okay? And then here's the value I am finding with 99% left. So I am finding the context bound with 99% left. And then that spits out the x value. So here for number 20, we are finding a standard deviation. All right, so you remember that if you're finding a mean or you're finding a standard deviation, that is the only time you don't have a choice. You must get the z-score from the standard normal model, if the percent they give you, okay? Get the z-score, and then you must use this z-score formula to solve algebraically for, in this case, standard deviation. If it had asked for a mean, we would have the mean missing, and we would solve for that. So here you go. So again, remember that to get the z-score, z-scores are on the standard normal model. So I put into DESMOS in with 0 and 1. Okay, a standard normal model with 0, 1. I found the bound with what did it say? The 18% to the right. And so that's how I got a z-score of 0.92. And so that's what I put right here to then solve algebraically for standard deviation. All right, moving on. Okay, so this problem here said the 3 standard deviations up, what's the most expensive? And so you can put that into DESMOS, or you can just add 3 standard deviations, whatever you want to. Here again was finding the proportion. So that is finding an area, and it wants to do it above 3.75. And so that gives me the area of 28.05%. And so then here's this next one, and it is the proportion, one of those P words. So it's looking for the area in between 3 and 3.5. So that is an area of 37.75%. All right. So now what's the cutoff price? So that is asking for the X value of the bottom 20%. So I went and I put the context normal model in because I want context to come out. If I want X, I do the bound with context normal dist. If I want Z, I do a bound with the 0, 1 normal dist. That's the standard normal distribution. And there we go. It was at 314 or less. All right. Now, this one some students miss if they don't get the decimal correct, because if it says that 0.5% is the overflow, then when you move the decimal twice, this actually is the decimal 0.005. So that 0.005 is the area that's up here. So I want to find the bound. So what am I solving for? Oh, looky here. I am finding the mean. So this is when you don't have a choice. You have to get the z-score first. So get the z-score with the standard normal model, bound with the, look, right 0.005. So that's a z-score of 2.5 that I plug into the formula to solve for the mean. So then the math to solve for that mean is I'm going to multiply both sides by the 0.4, and then I'm going to subtract that 8 over to the left. So then I have a negative value equals the negative mean. So the mean, multiplying through by the negative gives me the positive 6.968 or 6.97. Again, love that one. 6.97 for the mean. All right. Okay, this last one. This one's a fun one. So here we are finding the proportion. So we are finding an area to the right of 48 inches. So the tricky part about this one is you had to turn all units into inches. So you had to go from the feet to inches. So the height, the average height was 4'3", which is 51 inches because that's 4 times 12 plus 3. All right, and then it asked about, oh, look, I didn't have a good picture here. I didn't finish drawing the picture. So if this is our average at 41, this asked about the proportion above 48. And so it was asking for this area up here. And so I'm thinking, wrong. Yeah, it's so let's see. Something's going, oh, never mind. Okay, sorry. I did some things wrong here. Okay, so let's go back. The mean is 51. Okay, that makes much more sense. The mean is 51. So that my 48 is down here. And so you would have to duck to enter into their home if you are taller than 48 inches. Okay, so that's how I got the area to the right above 48. Okay, and so now the next one here. So this one's interesting. This one was talking about that you had to be in this height range to get to sing in the ceremonies. So when it asks who would be left out, you actually have outer area that gets left out. So that was interesting, but it's so easy in DESMOS because we can just compute the outer area for, greater than 56 and less than 50, and then it gives you that amount right there, 31.47%. So I guess this should be a 47. That's what my DESMOS says. All right, and the last one, what's the height to separate the top 10%? So it's asking for the X. That's a bound with context normal model. So then there we have the 53.56 or more get left out. Here's a picture of pygmies standing next to a westernized person. So there you go. All right. So I hope that you are starting to feel comfortable with this normal model material. The test does have 3 free responses, but the rest is multiple choice. And on the multiple choice ones, you do not have to show the work for those, but you do make sure you want to show all the work on the free responses. All right, so good luck to you on that assignment, or this assignment, and good luck to you on your test.